Cool. All right, so hopefully my closed captioning is also working down there at the bottom of the screen. I'm going to go ahead and just jump straight into my material. So today I'm going to be talking about VM detection and why it matters. But first, a little bit about me. There we go. My name is Tillery. I have been doing a lot of things for a long time. I started my career in education as a math teacher and pivoted over to data science from there. And my data science then led me down the cyber threat intelligence path, which got me into CNO in general. So it's kind of not a typical path into hacking, but it's my path and I like it. My focus as a CNO professional has been primarily in vulnerability research, which is very heavy in reverse engineering. Mostly that's been on Windows. Some of it has been malware related, but most of it has been finding new vulnerabilities. I accidentally became a pseudo expert in file and network protocol analysis because that's the things that I worked on at work. I've never looked at malware as my primary focus, but it's always been a hobby. And a lot of techniques that we see in malware are actually also very useful for initial exploitation or things like dropping our stage 1 and our stage 2. So what I'm going to be talking about today is mostly focused around things in the reverse engineering realm, because we're going to take those concepts and then forward engineer them into things we want to do. So what are we doing? Really, when it comes down to anything offensive in the red team world, we're going to be running some kind of code, and we're going to be running that conditionally. We want to make the right call on what we run, how to run it, and when to run it. And that's one of the steps that really separates a beginning red teamer from a more experienced red teamer, is knowing you don't just throw everything at the wall and see what sticks. You do a lot of kind of enumeration and target knowledge to figure out what we actually want to be doing and what our path forward is. So to do that, we need to know our environment and we need to know our goals. And once we know those two things, we can make the decisions on what we actually want to do and where we actually want to go. But there are a lot of considerations to take into account when we're doing that. The first and most obvious one is going to be the operating system we're running on, but there's a little bit more to it than just saying I'm on Windows 10. You might have different payloads for different versions of Windows, Windows 10, Windows Vista, or even different patch levels of an existing VM. I've had vulnerabilities that I've written that didn't work on SP1, but did work on SP0, and that's kind of an obvious one. But even sub-patches, KBs that are released in the intermediate can have a huge impact on vulnerabilities that are present. Even beyond OS and patch level, things like languages can also have a huge impact to exploit development and your exploit landing. And here I'm not talking about like Python versus C. I'm talking about, is this a English version of Windows or is this a Spanish version of Windows? Is this a Chinese version of Windows? Because that can have a lot of differences in the environments that are created in an environment of variables. In particular, when you're doing weird things with the heap, that starts to matter. Now, me as a red teamer, I care about that a little bit less, other than knowing different versions of my exploit might have different requirements and that I need to worry about that. For me, I generally consider the operating system piece someone else's problem when I'm doing red team type engagements. If I'm doing exploit development, I absolutely care about that. But by the time I'm actually ready to throw something, someone else is going to done some module that determines what operating system I'm on. They'll do that kind of initial triage for me. Another big problem, and one that most people ignore, is whether we're on bare metal, that is not running inside of any kind of virtualization, or if we're in some kind of VM. And VMs can come in lots of different forms. They can be a lightweight software hypervisor, something like VMware Fusion. They can be a hardware hypervisor like ESXi or Hyper-V. And that's going to change a lot about how we want to run and why we might want to run. For one thing, the intention behind a user running on a bare metal system can be very, very different from somebody running everything inside of a VM. As we've already seen with the CTF that's running today, all of the analysis we're doing is being done inside of VMs because we want to isolate it in some way. And by being inside of a VM, that gives us some protections as analysts. But as an attacker, if someone is trying to analyze my code, I might not want that to happen. So why do we care? Because we're evil people doing evil things, and we want to make sure that our evil things are done successfully. We want to avoid detection. There's going to be target enumeration for things like tools and alerting that we want to make sure we don't trigger. Again, for the purpose of this talk, that's not my problem. We also want to know if this is a production system or a development system. A lot of development is done in VMs. A lot of production systems these days are containerized, and detecting those things is useful, and knowing the difference between them can be useful. There's also a lot of development that happens on bare metal. So back in the day, malware would typically detect, am I in a VM, and then do nothing. Now it's a little bit further than that. Am I in a VM? If so, what kind of VM am I in? Does this look like it's a developer system, or does it look like it's maybe an analysis system? Make a decision based on that. Because at the end of the day, our goal is to be able to do our thing without getting caught. If we're throwing 0 days, we don't want those 0 days to be burned. Even if we're not, we're throwing off-the-shelf exploits. The last thing that we want is for them to detect our initial access and lock it down so that we can't do anything interesting after that. Most malware analysis, when we're looking at just a piece of malware, happens in an enclaved VM of some kind, something like Cuckoo Sandbox or throwing it into a VMware VM. But in addition to just kind of that enclaved analysis, we also care about the tooling that's available in VMs. For example, in Hyper-V, we have concepts of credential guard where we can't do our pass the hashes easily. We have concepts of more memory mapping and more memory controls that happen at virtual trust levels above just our kernel. So the mitigations that are involved in those kind of hardware hypervisors are different. And we need to know that sort of thing as exploit developers and also as people throwing these exploits. So at the end of the day, we need to know our target and know as much about our target's environment as we can. And all of that knowledge is really just informing our goal and how we reach that goal. If we don't know what our goal is, that can be very, very difficult. Okay? So I'm going to jump in next. I'm going to kind of hand wave away a lot of the knowing your goal, because I'm assuming by the time you're ready to throw exploits, you know something about your environment and something about the goal that you have. So let's talk a little bit about knowing your environment. Target enumeration of some kind is always going to be that first step. Before you ever throw a payload, you want to know as much about your environment as you can without arousing suspicion. So often you'll do passive things over the network for that. For example, if you just ping a system, that'll tell you if it's Windows or Linux. There's a lot you can figure out just from network packets that are flowing over. There's also some other enumeration that you can do on specific versions of software or specific versions of Windows. Since I don't care as much about that for the purposes of this talk, again, I just care about am I in a VM or not. There's not as much that you can do prior to throwing something, but you want to find out as much as you can, as early as you can. If it's some kind of knowledge that's going to change how you act, you want to figure it out. So OS, patch level, and very crucially, again, whether or not this is a VM. We need to know our goals, because like all things, enumeration has levels. We don't want to do really coarse enumeration that will trip sensors in the network, for example, if we don't need to know that. But some methods are innocuous, and so they're not detected and it's safe to do them. If it is a noisy or suspicious method, we might only want to do that if we absolutely need that information and can't get it another way. So we only want to scan as deeply as we need to reach our goals, and then stop. This applies to initial target enumeration before we ever land on a box, but it also applies to target enumeration after we land on a box. And that's kind of why I'm including this information now, right? We don't want to do really deep scanning that might trigger a personal security product, a PSP. We don't want the virus scanner to alert before we've even dropped a payload, because then when we do drop a payload, they're going to grab that, detect it. So we do want to scan for things like specific assets that might exist or information about the specific box we're on, the OS, the level, if we even care about being analyzed, because sometimes we don't. And all of these things we want to do prior to actually running our exploit. Okay, now that we have that background out of the way, my goal now is to know if I'm running on a VM. I don't, for the purpose of the rest of this talk, care about the why. I've just determined that for some reason, I want to know if I'm on a VM. With most things that are offensive, I'm going to take my lessons from the way that malware is doing it in the real world right now. Because other malware authors are just as evil as I am when I'm writing malware. So their skills, their techniques can inform my skills and techniques. So everything I'm going to be talking about for the rest of this talk is techniques taken directly from malware and seen in the wild. Okay? The key to determining if you're inside of a VM is to know that every kind of sandboxing, anything that we can do to isolate, has fingerprints. Nothing can be perfect. So we want to find what things are there that tell us or give us hints that this might be a virtual environment. We want to find our anomaly, and that gives us our answer. There are really kind of two categories of ways to do this. One of them is passively by things that are kind of already on the system, and one of them is actively by doing kind of deeper queries. But those can be further subdivided as kind of software, network, and hardware. I'm going to jump in first with a deep dive into how we do some of this hardware enumeration. I'm going to start with the brains of the system, the CPU. Right? It turns out that getting information about the CPU, especially on Intel and AMD devices, is really easy because there's an instruction built into the assembly language that gives us a lot of this information back, and it's called CPU ID. It gives us a whole bunch of information based on what we pass in our EAX register, which is telling it what kind of query we're making. For us, it's really interesting that we can get things like the vendor or the brand or even the hypervisor that's running the CPU. That tells us right immediately out of the gates whether we're running in some very common virtualization systems. Because if we're in KVM or Microsoft Hypervisor, VMware, Xen, even VirtualBox, all of those have hypervisor, vendor, or brand designations that we can use to determine that we're running inside of them. If we're in an analysis environment that's specifically trying to hide the fact that it's a VM, these values might be changed. But if you're just creating a VM from scratch in VMware, then it's going to have a CPU with a VMware vendor ID in it. Really handy for us to detect. You can learn a lot about a system from querying its CPU, even outside of those names, though. We already talked about brand, vendor, and hypervisor matching a known VM value. Some of those are strings. Some of those are particular integers that represent something that we know. But we can also figure it out based on just the CPU's capability. Do we only have one processor with 2 cores? There's a very good chance that that's not a real world system. Because it's 2020, very few actual machines are that limited, but that's the default configuration for most VMware VMs. So we can make that determination purely by the number of cores and the number of processors. That's not foolproof, but it's at least one piece of information that we can plug into a heuristic. But there's more that we can learn, even from the CPU, than just the information that is given back to us by the chip and by the kernel. Things like timing. Do certain things take longer than you expect them to? Is it supposed to take a long time, but it takes a short time? It's probably being short-circuited in the VM. Is it supposed to take a short time, but it takes a long time? There's probably some kind of VM bridge information that's making that longer, or some other kind of piece that's happening. Or are timings artificial? For example, if I sleep for a minute, but it immediately returns and my tick count is wrong, I know that that's an artificial timing, which means that I'm running in a VM that wants to short circuit that analysis. And that's because back in the day, a really common way to hide from automated analysis of malware was to just wait until they give up. Because a lot of sandboxes, things like Cuckoo, are configured to do a scan for some period of time. And if nothing malicious happens during that period of time, it marks it as benign. Well, okay, malware is just going to sleep for a minute and then it's done. Analysis authors then take the other side of that cat and mouse game. Now they're going to short circuit sleep so that it returns immediately. Okay, well, the next step, malware is going to say, did I sleep? And did my tick count change appropriately to the sleep? The tick count is the actual timing on the processor that says how long things have taken. It's usually gotten from a API call like get tick count in Windows. Okay, well, the next step then is for our hypervisors to also artificially increase the tick count. We can kind of see these things going back and forth. So we can determine if we're on a normal VM or an analysis VM, or if we're on bare metal by a lot of kind of these traits. There's also VM-specific opcodes that only happen in the case of a hypervisor, like a hardware hypervisor. Things like the VM exit instruction in Intel assembly. There's separate instructions for the AMD extensions instead. But at the end of the day, there are some VM-specific opcodes in the VMX subsystems that behave differently if you're on a VM, especially a hardware hypervisor VM like Hyper-V, versus on bare metal. So timing and interaction between those things is also a really good source of information for that. Stepping away from the CPU, let's go to the system as a whole. In the system as a whole, we have other devices that we can look at, especially things like NICs, network interface, and that can give us a whole lot of information about the system. For example, one of the first things that I do is check for the MAC address of the NIC. And if it's one of these 3 known values in the EUI-48, then we know that it's a VMware VM. The EUI-48 is actually split into 2 pieces. The first half of it represents the vendor, and the second half of it represents a unique identification code for just this interface card. If the first half of it matches one of these 3 values that I have on the slide here, we know it's a VMware Mac. Or they're trying to look like they're a VMware Mac really hard for some reason. Okay? So that gives us a really good hint, just kind of glaring, that it is a VMware VM. And there are similar values for other hypervisors as well. We can also look at the network adapter name, because if we query the adapter name and we're inside of a VMware VM, the network adapter name literally contains the string VMware. So by the fact that that string is there, either they're pretending to be a VMware VM or they are a VMware VM. We also have certain pseudo devices that are created only in VMware installed systems. HDFS and VMCI are 2 examples of that. So we can query those actually 2 different ways. One of them is to see if those devices exist at all. Just try to open those devices via the normal C API. If you're able to open them, they exist. If they exist, then this is probably VMware. We can also query the system serial number. Lots of ways to do that. The kind of easiest way is using WIMI, which is just a scripting kind of querying interface for Windows. If that literally contains the string VMware, we again know that this is a VMware VM. All of the kind of examples that I have in these slides are focused on VMware, but all of these techniques with kind of varying definitions, varying things that we're looking for, exist for other hypervisors as well. And for VMware in particular, and VirtualBox and Xen, for all of the ones that I kind of listed earlier, at their core, they're not intended for malware analysis. They're just ways of virtualizing. They don't really try to hide the fact that they're a VM. So you can check for a lot of things that would be present only in VMware, only in those installs, because they're not trying to hide them. And the easiest way to do that is to check for some of those drivers that we were just talking about. We talked about that HDFS file system. Well, there's going to be a driver for that inside of our drivers directory. We may have VMware tools installed, and part of VMware tools is going to drop a particular value into our registry. There's also a VM mouse driver that gets dropped. If any of these things exist in the registry or on disk, that's going to tell us a whole lot about what kind of system we're in. Right? In addition to those, there are also some special device mappings that VMware makes. All of those names contain VMware, and they're all really easy to scan. So if we check our device map for our SCSI ports, port 0, port 1, and port 2 all have VMware in their name. So just by querying those registry keys, or by querying our device map at the device level, we can determine that this, again, is a VMware system. Okay? So we have a whole bunch of things to check here, and most of the ones that I've introduced are VMware specific. Once we have all of this information, we can build a heuristic. And the most simple heuristic is just to take all of our general VM checks, things like the CPU ID results, timing, take all of our VMware specific checks or VirtualBox or what have you, combine all of those with some kind of weighted average based on the things we think are more important, set an acceptable threshold that says, if my result is higher than 5, I'm on a VM, and get that value back. It's really that simple, okay? In Scythe, I've implemented a module called VM Detect. Version 1 detects the presence of some of those general artifacts, the ones that I talked about in these slides, as well as all of these VMware-specific artifacts. And it tells you a certainty level. Right now, it's using the weighting that I used. It's not configurable, but it's something that I intend for future work. It is a capabilities module, so it's literally just implementing 4 functions. Those 4 functions are getting things like getting its configuration information and the ability to run it. So once it's loaded, you just call run, and it gives you back a number. You can take that number as part of your decision-making inside of Scythe on whether or not to run the next step in your exploitation. Maybe you decide whether or not you're going to throw a payload based on the result that you get back. A certainty level, for example, of 5 could say, don't move on to the next step because I'm running inside of a VM and I don't want to run there. A value lower than 5 might mean it's safe to go ahead and run that next payload step. All right, so that version 1 is only a few general artifacts and a few VMware artifacts because I wanted a proof of concept and something that people could kind of play with. I'm going to release the source code for that on my GitHub fairly soon. I need to clean it up just a little bit, and it'll kind of serve as an example of how to implement some of these modules for you. I'll make sure that the Scythe team throws that out on Twitter as well, so that if you are interested in taking a look, you can do that. VM Detect version 2, I'm much more ambitious about. I want to include additional hypervisors. In particular, Hyper-V, VirtualBox are interesting to me, maybe also KVM and Xen. Those are a little bit less interesting because they very rarely run Windows hosts, and a lot of the detection techniques that I'm interested in are Windows-based because most malware targets Windows. I also want to add a whole lot more generic detection methods, things like the behavior of mouse activity, names of different parts of the system, and also some common sample names. For example, do we have infected.zip on the desktop? If we do, then we're probably running inside of a VM that's doing analysis. Disk size is another really good one. If we're on a system that has less than 40 gigs of hard disk, it's probably a VM because no real system these days has that small of amount. It would be completely unusable. Whether or not sleep is patched, like we talked about, the difference between sleep and tick count, differences between getting information from the APIs and get processor info, get proc info versus the actual raw access via assembly, things like physical memory size, and then crucially, uptime. That's actually my favorite way to determine if I'm in an analysis VM. If this system has been up for less than a minute and it's already looking at my stuff, then it's probably a VM. It's probably a sandbox VM that's detonating something really quickly. So I'm not going to run. But if it's been up for an hour, it's not probably a sandbox or it's artificial. So that gives me at least a piece of the heuristic. I also want to add things like hook detection, configuration of the heuristics, so you don't just have to use my numbers, debugger detection. Really, the list goes on because our work is never done. There are so many things that are different between the different types of hypervisors and between bare metal and actual installations. So I'm just slightly over time. It looks like I'm at 20 minutes and 30 seconds, which is good. I'm happy about that. Grim, the company that I work for, is really easy to reach on the web. We are at Grim Cyber. Scythe and Grim are sister companies, so we work really closely together. I am actually the director of cyber training at Grim. I run the entire training group, and I also work with our application security team. So Grim's really easy to reach on the web. Feel free to reach out, and so am I. Here's my Twitter, GitHub, my email addresses, and of course, if you're going to send me email and want to encrypt it, you can grab my PGP keys from my website as well. Since I'm a little bit over time, I'm not going to be able to take questions here, but I will be sticking around in the Discord for quite a while, and I'm happy to chat about any of these techniques or really anything else with you all.